process is very different than the fraction process, but you need to make sure you are leaving answers in simplest form. So we are going to be dealing with more than just square roots, okay? I think up until this point you might have just done square roots. We're also going to do cubed roots, fourth roots, and so on. Square roots, you're always looking what multiplies by itself twice to get certain numbers. Cubed roots, you're going to be thinking about what multiplies by itself 3 times to get certain numbers. Fourth roots, 4 times, and so on. So your perfect squares list, and you should be familiar with these, but because you guys do have a calculator, you can always check out perfect squares by just trying to take the square root of them. Obviously, 2 squared gives you 4, which is why 4 is a perfect square. 3 squared gives you 9, so 9 is a perfect square. All of these numbers we can take square roots of. All of these variable terms we can take square roots of. What do you notice about all of those variable terms and what they have in common? What makes them all perfect squares, Georgia? Right, even exponents, right? The square root of x squared is what? X. The square root of x to the 4th is x squared, right? Essentially, however many times 2 goes into that, so the square root of x to the 6th is x to the 3rd, right? You know your exponent rules, right? We can all agree that x to the 3rd times x to the 3rd gives you x to the 6th. You can also think of that as x to the 3rd squared gives you x to the 6th, which is why the square root of x to the 6th is just x to the 3rd, because the square root and the square cancel on the left. So, perfect cubes, 2 times 2 times 2 gives you 8, so 8 has a cubed root of 2. 27 has a cubed root of 3, because that's 3 times 3 times 3. 64 has a cubed root of 4, and 125 has a cubed root of 5. Do you guys know how to find the cubed root button on your calculator, or any root button on your calculator? Square root's obvious because it's right there in blue, right on your main screen. That's the square root. If it's just a radical, the assumption is square root. Under your math menu, there's your cubed root. So option 4, you could find the cubed root of 27, and you get 3. And it doesn't have anything else stored in there. So it doesn't have like a 4th root option, a 5th root option. If you want to do any other root, you have to use option 5. And you actually have to put your root number in first. So for example, if I wanted the 5th root of something, I would actually have to hit my 5 first, then go to math, go down to my 5th root of 32. Does anyone know what that is? What multiplies by itself 5 times to give you 32? This will tell us 2. Correct. So obviously 4th powers and 5th powers get big much faster, so we're familiar with less. But look at your perfect cube variables. What do you notice about all their exponents? Right, they're multiples of 3. So 3 goes into 3 once, so the cubed root of x to the 3rd is just x. The cubed root of x to the 6th is x squared because 3 goes into it twice. Okay? The cubed root of x to the 9th is x to the 3rd. The cubed root of x to the 12th is x to the 4th, and so on. 4th powers, your exponent needs to be a multiple of 4. 5th powers needs to be a multiple of 5, and so on. Okie doke? Any questions? Okay, we're good? Next, here's breaking down radicals. So the first 2 are both square roots. They don't have a little mini number there. Are we good with that? Okay. You need to find the biggest perfect, if you're finding the square root, you need to find the biggest perfect square that goes into 27. So hopefully you'll become familiar with them and you won't have to look at a list, but what's the biggest number that goes into 27 evenly, Sierra? 9. 9 times what? 3. So I'm going to keep the negative sign there, and I'm going to break down 27 into 9 times 3. But it's going to be root 9 times root 3. Because that's an equivalent breakup of root 27. And I do that is because the square root of 9 I can actually evaluate. Tess, what's the square root of 9? 3. And there's your simplest form. You always want to double check that a perfect square doesn't go into 3 as well. Okay? Next one. 9 root 242. So root 242. Look at your list. Find the biggest number that goes into 242 evenly. Chris? 121. Specifically 121 times what? 2. So I'm going to break it up into root 121, root 2. So that multiplication is an okay equivalent breakup of 242. And then the square root of 121 is 11. Now, these are all multiplied. It's 9 times root 121 times root 2. So really, it's going to be 9 times 11 root 2, which will give you 99 root 2. Does this make sense? Have you done this before? You have. Probably right before you did the quadratic formula, just to make sure you broke that down. Cubed roots, probably not. What is the biggest perfect cube that goes into 54? Oh, by the way, negative 8, negative 27, and negative 64, and negative 125 are also perfect cubes. Because you can take the cubed root of a negative number. Something can multiply by itself 3 times and give you a negative number. That can't happen with square roots. If you multiply a number by itself twice, and only twice, it's either going to be a positive times a positive, which will be a positive, or it'll be a negative times a negative, which is a positive. So these numbers have to be positive if we're taking the square root, but cubed roots are different. That's issue 1. So what is the biggest number that goes into negative 54? Morgan? Negative 27. So we want the cubed root of negative 27. And it's 27 times what? 2. So negative 27 times 2 is essentially replacing negative root 50 or negative 54. And then the cubed root of negative 27 is Owen? Negative 3 cubed root of 2. Make sure your little 3 is little. And make sure it's nestled in that little radical crevice. I don't want that to look like another coefficient, because that will be wrong. Okie doke. And here we have a 5th root. Look at our 5th root list. Oh, please, does 32 go into that? 243 divided by 32. No. Uh-oh. 5th root of 243. 243. Okay, so 32 doesn't go in. We can try whatever 3 to the 5th power is. 3 times 3 times 3 times 3 times 3. Oh, that is that. The 5th root of 3 times itself 5 times gives you 243. So the 5th root of 243 in and of itself is just 3, which will just give you negative 6. Make sense? Okay, variables. Now this has a number term, which we're going to do the same. What's the biggest perfect square that goes into 32? 16. So root 16, root 2. When you're looking for a square root, your exponent needs to be a multiple of 2, aka even, right? Is 7 a multiple of 2? No. But if you go just underneath 7 to 6, x to the 6th we could take the square root of. So we're going to break down x to the 7th into x to the 6th times x. That's using your exponent rules a little bit, right? Do we all agree that x to the 6th times x is an okay replacement for x to the 7th? So now this has a square root of 4. And the square root of x to the 6th is, how many times does 2 go into 6? 3. So that's just x to the 3rd. And then the root 2x, the 2 and the x are just sort of still locked up. Does that make sense? Okay? So when you get to oh, this is a square root again. Jump over to a cubed root. First of all, the cubed root of 8 can stay the cubed root of 8 for a minute. That doesn't need to be broken down because I know that the cubed root of 8 will become a 2. But with an x to the 4th, does 3 go into 4 evenly? What's the first number under 4 that 3 does go into evenly? Right, so I'm going to break that up into the cubed root of x cubed times the cubed root of x. I'm replacing x to the 4th with x cubed times x. Does 3 go into the 2 on the y squared evenly? No. And I actually can't reduce that to anything, so I just leave it. And how about z to the 8th? Is 8 divisible by 3? No. What number underneath 8 is? 6. So I'm going to break up this into the cubed root of z to the 6th times the cubed root of z to the what? What's going to replace z to the 8th? Z to the 6th times z to the 2nd. Do you follow? So when I go through, I have my negative 2. I have a 2. The cubed root of x cubed is x. The cubed root of z to the 6th is what? Oh, is that our bell? Hold on, I got to give you homework. What is the cubed root of z to the 6th? Z squared, right? Z to the 2nd. So on your homework, I'm going to adjust just a little bit. You only have to do the first and the second parts. You obviously picked up your spark right here. So don't worry about the top yet. Just do part 1 and part 2. And that's it. Because we didn't get to adding and subtracting and so on. Who said that? Too strong. I feel like you need